Okay, so we're going to go to our booklets now. I am on page 28, which is where I've written about the effect of temperature on the rate. So I've gone through worked example there, and then I talk about catalysts, and I've gone through some worked examples there. Okay, so have a look at those before you go to the questions. We've done up to question 6, so we're going to start in question 7. I want you to do from question 7 down to question 15, so do all of those questions. Please pause the video and do them by yourself. Don't just stay and watch me do them. Okay, so pause me, do the questions, and then when you're finished the questions, then press play again and come back for the answers. Okay, so I am going to go through the answers. 7, it says the graph on the right shows the rate at a number of different temperatures for reaction between marble, blah, blah, blah. Describe how it changes as the temperature is increased. So you see on the x-axis, you are increasing the temperature. On the y-axis, as the temperature increases, you see that the y values are also increasing. So I can simply say that an increase in temperature, increased temp, leads to an increase in the rate of the reaction. And when it asks you to explain this effect, I'm going to write this one down here because it's usually a 3-mark question when you're asked to explain the effect of temperature. So you need to tell me 2 different things. You need to tell me that the particles are moving faster, or something along that lines. Particles are moving faster, so they collide more frequently. Don't just say collide more, you have to say more frequently, or collide more often, or something along that lines. Particles moving faster, so they collide more frequently. You also have to say more particles have the necessary activation energy. And because more particles have the necessary energy, you get more successful collisions. So what I mean by a successful collision, as I told you before, that not every collision, not every collision is going to result in a reaction. Sometimes they collide and they just bounce off each other. For it to be a successful collision, they have to collide with enough energy for them to actually react. And if they've got more energy, which they do at higher temperatures, then more of those collisions will actually be successful and result in a reaction. So you need to mention all of those points when you're talking about temperature. Then it asks you to state 3 variables that would need to be controlled. So you're trying to see what effect temperature has on the rate of the reaction, which means that anything else that can alter the rate of the reaction has to be kept constant. So we've looked at all those other factors, okay? First one we looked at was surface area. So you would need to say that the surface area of the marble chips is the same each time. Okay, we've looked at concentration, which is the amount of the reactant. So you would say the mass of the marble and the concentration of the acid, they have to be the same each time. So you can say the concentration of the acid, you could talk about the volume of the acid, the mass of the marble, that all has to be the same. You're not going to talk about pressure because you're not talking about gases. The other thing we had was catalyst. So you could say you're either doing the reaction with a catalyst or you're doing it without, but it has to be kept constant. Okay, so their variables you would keep the same. State and explain the effect of using the same mass but larger pieces. So if you're taking the same mass but you're cutting it down, if you're using the same mass but you're using it in big pieces instead of small pieces, then you have decreased your surface area. So you are going to decrease the rate, because if you're using a large piece, you have decreased the surface area, which I'm going to abbreviate to SA. So you've decreased the rate because you've decreased the surface area. One big chunk has less of a surface area than that same chunk ground into lots of little pieces. Experiment repeated with answers twice as concentration, 2 differences. So if you are increasing the concentration, we've already seen that this increases the rate. So that's the obvious difference. The second difference, okay, if you're increasing the concentration, that means you are starting with more acid. And if you're starting with more acid, you are going to increase the amount of product. Okay, so I think I said this before in the last video, if you were making a cake and you doubled the amount of your ingredients, you're going to end up with more cake at the end of it. If you're increasing the concentration, you are starting with more reactants. Start with more reactants, you're going to get more product. And you're going to get it quicker because there's going to be more frequent collisions if there's more particles in that beaker. What effect does a catalyst have on the rate of a reaction? It increases the rate of a reaction. What effect does a catalyst have on the yield? That word yield just means the amount of the product that you're going to get. So we've said the only thing that affects the amount of the product is the concentration, okay? A catalyst will not affect the yield of the product, so it's got no effect effects on the yield of the product. You're going to get that product quicker than if you didn't use a catalyst, but it's going to be the same amount. Describe the use of a catalyst as environmentally friendly. There's actually one or two things you can say here for 14. So for 14, one thing you can say is the catalyst can be reused because it's not used up over the course of the reaction. But something else that you can say is because the catalyst lowers the activation energy, that means particles themselves need less energy to react. And if they need less energy, then you can do the reaction at a lower temperature. So for example, say you were doing a reaction and you needed to crank the temperature up to like 400 degrees Celsius in order to get the reaction to work. And then you chuck in a catalyst and you can reduce that temperature to 200 degrees Celsius because you've lowered the activation energy. The particles don't need as much energy, so you can do it at a lower temperature. If you're doing it at lower temperature, then for you, it's you're using less energy. So lower temperature means less energy. Because if I wanted to create a temperature of like 400 degrees Celsius, I would need to use a lot of energy. I'd need to use a lot of electricity in order to create those really, really high temperatures. And every time you're using energy, you are typically burning fossil fuels. And when you're burning fossil fuels, you are producing CO2. And to be fair, there's a few bits in that question that we haven't really covered in detail yet. We look at energy in a later topic, and we look at CO2 production in a later topic. But essentially, less energy required means you can do it at a lower temperature. Less CO2 is going to be produced. Question 15. It's really long. Apologies. I've given you a little graph in there. What have I asked to do with this? Say the change that can make the apparatus. So this whole thing here is apparatus. You want to measure the volume of the gas more accurately. So this part of the apparatus, the measuring cylinder, that's what's currently measuring the volume of gas. What's more accurate than a measuring cylinder? What we used and what we talked about already, a gas syringe will be more accurate than using a measuring cylinder. A tangent has been drawn to calculate the rate of reaction. So they have drawn you a tangent. You just need to calculate the gradient of that tangent. That will give you the rate. If you want the gradient, then you need to get 2 points on the line. I'm going to take this point here, the one that actually cuts the x-axis, sorry, the y-axis, but you can take any point that you like. So I'm going to call this point here, it's 0 on the x-axis, and on the y-axis where I've drawn it, I would say it's roughly halfway. I'm going to call it 15. And then I'm going to take another point, and the other point that I'm going to take it just here where it is at 40 on the y-axis. And on the x-axis, that point there will be, what's going to be in 5s? 44, 48, I'm going to call it 52. So there are my 2 points. You can pick any 2 points on the line, but once you've got your 2 points, you need the change in y. So this is my x point, this is my y point, and I need the change in x. So the change in y, I have got 40. Right there. I've got 40 and I've got 15. So my change in y is 25. And my change in x, I've got 52 and 0 is 52. So 25 calculator is 0.48. So my answer is 0.48. I'm going to fill that here on my answer line, 0.48 centimeters cubed per second. Okay, if they didn't give you the unit on the line, you just look at your axes. You've got centimeters cubed on the y, you've got seconds on your x, so it's centimeters cubed per second. Anything in and around 0.48 is going to be fine depending on the points you chose. Okay, they always give you a little bit of a range. On the graph, draw the line you would expect if the magnesium ribbon was replaced with an equal mass of powdered. So same reaction, but you're taking that ribbon, okay, so this piece of metal, and you're grinding it up into a fine powder. If I'm making it a powder, I am massively increasing the surface area. If I increase the surface area, I increase the rate. And to show on the graph that the rate is getting faster, I am going to be drawing, I am going to be drawing a steeper line. So it's for 2 marks. You get your, really often. You get your first mark for just drawing a really steep line, and you'll get your second mark for leveling it off at 40 centimeters cubed. Okay? Yes, the reaction is quicker, but they tell you you're still using the same mass of magnesium, you're just grinding it up into a powder. You have the same amount of reactants in there, the amount of products is going to be the same. So 1 mark for a steeper line and 1 mark for leveling it off at the right point, which is going to be 40. The last question, it's a 6 marker. Let me see. 2 substances A and B each form a colorless solution. If the solutions are mixed in a beaker, blah, 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 blah. Right, okay. If you compare the 3 experiments, you will see that between experiment 1 and experiment 2, you are increasing your temperature. You're going from 20 to 40. And when you go from 20 to 40, in experiment 1, it took 320 seconds for that cross to become invisible. It only took 80 seconds in experiment 2. That's telling me that my reaction is faster in experiment 2. The precipitate formed quicker, so my cross disappeared faster. So I need to comment on exactly why that is. I'm going to say that the increase in temperature led to an increase in rate. And you can refer to the table. You can say in experiment 1 it was 20, in experiment 2 it was 40. This caused this decrease in rate. I'm just not going to write all that out. Increase in temperature led to an increase in rate, and then you need to tell me why, and you need to tell me that the particles are moving faster. So you have got more frequent collisions. You also need to tell me that the particles have more energy, so more of them have the activation energy, and you've got more successful collisions. More have activation energy, more successful collisions. Okay, then you need to go back and look at your data, and you will see that between experiment 1 and experiment 3, you are increasing the concentration of A. And again, if you have a higher concentration and that same high temperature, you get an even faster rate. So now you need to comment on why increasing the concentration gave you an even faster rate. So you're just going to say increase in concentration led to increase in rate. And you're just going to write, I'm writing a space, you're going to write that there are more particles, so there was more frequent collisions, okay? Make sure when you're answering this that you're writing about more frequent collisions, not just more collisions. You need to talk about the 2 points for temperature, the fact that they're moving faster, the fact that they've got more energy, and in concentration, you're just talking about the 1 point. There's more particles, therefore there are more collisions. You can absolutely refer to the table in your answer. I have just been a little bit lazy and I've written an abridged version. Any problems with your 6-mark question, or if you want to take a photo of your 6-mark question and then email it to me, I'm more than happy to read it for you and tell you how many marks you would have gotten and tell you anything you would need to do to improve. So yeah, absolutely take a photo of it and email it to me if you want me to check it. Other than that, if you've got any other questions about what we've done in the last few videos, please just email me or message me on Show My Homework. Hopefully next week we'll have Teams and it will all be a lot easier. But until then, just message me on Show My Homework as much as you need to.